Hi, my name is Samir Desai, and in this video I'm going to teach you how to predict the product of an oxidation reaction.
Predicting the product of an oxidation reaction will be much easier if you familiarize yourself with where on the molecule the oxidation is likely to occur. The main thing to look out for is weak bonds between a carbon and a carbon, or a carbon and a hydrogen, because these are the regions oxygens can be added to. And as you know, an increase in the number of bonds to oxygen is one thing that characterizes an oxidation reaction. Depending on the reagent used, oxidation at a double or triple bond can result in the breakage of a bond. This is known as oxidative cleavage, which results in two aldehydes or two ketones, or it can result in the addition of bonds to oxygen. Oxidation can also occur at carbon-hydrogen bonds, specifically at the benzylic position, which is one position away from the aromatic ring due to the resonance that allows for stability, but also in carbons that are already bonded to an oxygen. There are two types of oxidizing agents to focus on: strong oxidizing agents and weak ones. Reagents like sodium dichromate, chromium trioxide, chromic acid, and hot KMnO4 are strong oxidizing agents, and you can see the trend that all of them contain a lot of oxygens. These reagents typically lead to the formation of an acid, although keep in mind that they can convert secondary alcohols into ketones. A secondary alcohol is a hydroxy group attached to a carbon bonded to two other carbons. Additionally, strong oxidizing agents have the ability to cleave pi bonds, like you would see in an alkene. They cleave it right down the middle to create two carbonyls in the form of an aldehyde or ketone. But there are also weak oxidizing agents that work similarly, in the sense that they form a new carbon-oxygen bond while breaking a carbon-hydrogen bond. The difference is that a weak one is not able to oxidize to the same extent. For example, pyridinium chlorochromate can oxidize an alcohol into an aldehyde or ketone, or Tollen's reagent, which can oxidize an aldehyde into a carboxylic acid. Both result in the reactant going from one carbon bonded to an oxygen to two bonds to oxygen, but this is different than a strong oxidizing reagent, which has the ability to add two extra bonds to an oxygen. Let's take a look at a question that will require you to apply this information in order to predict the product of an oxidation reaction. This question gives three reactants that react with oxidizing agents, and you're told to predict the product. The first step will be determining if the reagent is a strong or weak reagent before you can determine the product. Beginning with A, the reagent given is sodium dichromate. Now, is this a strong or weak oxidizing agent? Sodium dichromate is strong, meaning that it has the ability to convert many reactants into an acid. Looking at the reactant, oxidation will likely occur here because, if you recall, oxidation will occur at carbons bonded to an oxygen. So the resulting molecule will have a similar structure to the reactant, but the two hydrogens not drawn in the reactant will be broken, and at that same carbon, a double bond to oxygen will form. B has a similar structure to the molecule in A, with a secondary hydroxide bonded to the carbon that can be oxidized, this time with a different oxidizing agent, PCC. Pyridinium chlorochromate is a weak oxidizing agent, so unlike strong oxidizing agents seen in A that created two extra bonds to oxygen, PCC is only capable of breaking one carbon-hydrogen bond and creating one bond to oxygen. The alcohol would be oxidized into an aldehyde, and the result would therefore be 2-methylbutanal. Finally, C is a tertiary carbon with chromic acid, a strong oxidizing agent as the reagent. This has the ability to break one or two bonds to hydrogen, in turn creating one or two bonds to oxygen. While this carbon bonded to the oxygen is where we'd expect oxidation to occur, notice this carbon is not bonded to any hydrogens and is unable to be oxidized further. Therefore, there is no reaction. By this point, you should feel comfortable with identifying oxidizing agents, determining where the oxidation will occur, and predicting the product of an oxidation reaction. Make sure to follow this lesson with some practice.